A remarkable and unexpected observation by the James Webb Space Telescope has captured the close attention of scientists around the world. This development centers on a mysterious pattern of light detected in deep space, specifically in the form of signals resembling urban illumination. These signals were found at a staggering distance of approximately 7 billion kilometers from Earth. Such a discovery has stirred renewed debate and intrigue around one of humanity's most enduring questions. Could intelligent life exist elsewhere in the universe? The James Webb Space Telescope, which has been scanning distant celestial bodies in the hope of uncovering insights about planetary systems beyond our own, recently turned its focus to Proxima Centauri b, the exoplanet that orbits our closest neighboring star. In doing so, it captured unexpected bright emissions coming from the surface of this alien world. The light patterns appeared artificial in nature, unlike natural planetary reflectivity or thermal emissions. What makes this all the more surprising is that these luminous sources resemble the glow typically associated with densely populated, technologically advanced regions on Earth, such as cities at night. This discovery has prompted a range of questions among researchers and astronomers. What might be causing these unusual light patterns on Proxima Centauri b? Are they naturally occurring phenomena, or could they be evidence of artificial structures or technologies, possibly created by intelligent beings? While no definitive conclusions can be drawn yet, this observation has certainly revived discussions about the potential existence of extraterrestrial life. Humanity's quest to find life beyond Earth is not new. For decades, scientists have explored our solar system and distant star systems, searching for any signs that suggest the presence of biological processes or civilizations. Every time a potential clue emerges, no matter how uncertain, it generates widespread excitement and drives further investigation. The detection of light patterns from Proxima Centauri b is one such clue, drawing significant attention from both astronomers and the general public. According to ongoing analysis, the lights observed are unlike any natural phenomena recorded elsewhere in space. The telescope's sensors registered them as consistent with the type of artificial lighting used on Earth. Their regularity, intensity, and spectral characteristics suggest a pattern that would be difficult to explain through known geological or atmospheric activity alone. As such, some scientists have speculated cautiously that these lights could be indicative of a technologically capable civilization. NASA engineers and astrophysicists have been particularly fascinated by the implications. They are now asking key questions about how long these lights might have been shining, unnoticed by humanity, waiting for our instruments to evolve to the point of detecting them. The realization that such signals could have existed all along, beyond our reach until now, underscores how recent advancements in space-based observational technology are finally allowing us to perceive what was once invisible. David Kipping, a prominent astronomer at Columbia University, has noted that Proxima Centauri b exhibits unusual thermal characteristics. Unlike most rocky exoplanets that absorb light from their stars and re-emit it as infrared radiation in a predictable manner, Proxima b demonstrates a more complex thermal profile. The heat signature it gives off is markedly different from what is expected when comparing it to the radiation emitted by its host star, Proxima Centauri. This irregularity may be tied to artificial influences or unique environmental conditions on the planet. The James Webb Space Telescope is especially well suited to detect such anomalies. It is equipped with highly sensitive instruments designed to capture faint light in the infrared spectrum, a capability that allows scientists to detect even the smallest variations in thermal emissions and reflected light. This makes it an invaluable tool for studying the night side of exoplanets like Proxima b, where any artificial illumination would be most visible against the backdrop of space. The telescope operates by isolating and analyzing specific wavelengths of light that pass through or are reflected off a planet's atmosphere. Its ability to detect light in an extremely narrow band, far narrower than typical starlight, gives it the precision needed to identify subtle variations that might otherwise go unnoticed. In the case of Proxima b, this has made it possible to track and interpret the changing levels of light across the planet's surface over time. One particularly interesting aspect of Proxima b is the way it interacts with its parent star. The planet appears to maintain a distinct temperature difference between its sunlit and dark sides. On the day side, it is believed that some form of energy collection might be occurring, possibly through large-scale mechanisms akin to solar panels. Meanwhile, the night side experiences cold, persistent darkness. The presence of artificial lights in this region, if confirmed, would suggest the existence of power systems designed to maintain illumination despite the lack of natural sunlight. The role of the planet's atmosphere in regulating temperature and sustaining potential life is now a major focus of investigation. Scientists are studying the composition of Proxima b's atmosphere through infrared spectroscopy, with particular interest in identifying gases that could serve as biosignatures, such as oxygen, methane, and water vapor. These compounds, if found in the right concentrations, could indicate the presence of biological or even industrial processes. One of the challenges, however, is that the detection of certain gases, especially oxygen, is limited by the current capabilities of the James Webb Space Telescope. While the telescope excels at detecting water vapor, methane, and carbon dioxide, oxygen remains more difficult to identify. Nevertheless, the presence of ozone or combinations of gases that typically coexist with life on Earth could provide indirect evidence of habitability. It's also worth noting that the telescope has a limited field of view and can only focus on a relatively small number of nearby exoplanets. As a result, it cannot scan the entire galaxy for potentially habitable worlds. To address this limitation, astronomers are investing in future technologies. One such project is the Extremely Large Telescope ELT, a ground-based observatory, expected to be operational by 2028. With its advanced optics and significantly larger mirror, the ELT will allow for even deeper and more detailed analysis of planetary atmospheres. Scientists also look forward to the next generation of space telescopes, which will be designed specifically to overcome the current limitations in exoplanet detection. These instruments will aim to reduce glare from host stars, making it easier to observe the much fainter reflections coming from planets themselves. Such advancements will be critical in distinguishing between gases produced by living organisms and those generated by natural geological processes, such as volcanic activity or chemical interactions on a planet's surface. Although these investigations are incredibly complex and filled with uncertainties, each step forward brings us closer to understanding our place in the universe. The James Webb Space Telescope, despite its limitations, represents a major leap in humanity's ability to explore and analyze worlds beyond our own. It is helping scientists collect data that was once thought impossible to obtain, laying the groundwork for future missions and discoveries. Yet, despite all our efforts, no planet has yet provided definitive evidence of life. The question that has lingered for centuries still stands: are we truly alone in the cosmos? As research continues and our tools improve, the hope remains that one day we will find a clear answer.